Millions of people across the world stepped outside last week and saw something they never expected. Auroras, glowing, dancing northern lights stretching as far south as Florida. But this wasn't just a pretty sky show. Behind the scenes, a wild solar storm was punching Earth with immense force, disrupting satellites, delaying rocket launches, and pushing our magnetic shield to its limits. Here's what triggered the global light show. Dual solar storms fired off from the sun, arriving at Earth back-to-back. These storms came from giant eruptions called coronal mass ejections, or CMEs, huge clouds of plasma and magnetic fields launched from the sun's atmosphere. But this time, something unusual happened. Two CMEs lifted off only hours apart. The second one, moving faster, caught up, swallowed the first one, and combined into a single massive blast. When these merged CMEs slammed into Earth's magnetic field, they caused a geomagnetic storm so powerful it pushed auroras thousands of kilometers farther south than usual. Forecasters at the Space Weather Prediction Center call this a rare event, something you might only see a few times per solar cycle. And one CME was much stronger than predicted, with its magnetic field oriented perfectly to disrupt Earth's own. That's why the aurora exploded so suddenly and so dramatically. But geomagnetic storms don't just make the sky glow. They can disrupt communications, GPS, satellites, and even the power grid. The US and UK issued warnings to grid and satellite operators to prepare for possible disturbances. The effects were immediate. Jeff Bezos' space company, Blue Origin, had to delay launching NASA's ESCAPADE Mars mission. Why? Because high solar activity can damage sensitive spacecraft electronics. The mission was put on hold until space weather calms down. Meanwhile, in Scotland, sensors recorded the largest geoelectric field ever measured since 2012, 3.5 volts per kilometer, high enough to threaten transformers. The sun follows an 11-year activity cycle, and scientists believe we hit solar maximum in October 2024. But here's the surprising part. Even though the number of sunspots now slowly declines, this phase is when the most powerful flares tend to erupt. The region responsible for this week's activity sunspot group, AR 14274, has produced several X-class flares, the strongest category. One of them, released Tuesday, created the largest solar particle storm since 2005, and while this week's storm was intense, the third strongest of the current cycle. It still wasn't as extreme as historic events like the 1859 Carrington event, which set telegraph offices on fire. The active sunspot region is now rotating away from Earth, so future flares are less likely to hit us. But we're still in a period of elevated solar activity, meaning more auroras and more disruptions are possible in the coming months. So if you live under dark, clear skies, keep your eyes on the horizon. The sun is awake, the solar cycle is peaking, and Earth's skies are glowing in ways we've rarely seen in our lifetime.